We're going to extend our skill set from one sample Z and T test to paired differences, or two samples. First, let's look at when are two random samples independent. When sample data drawn from one population are completely unrelated to the selection of data from the other population, then you have two random independent samples. They're dependent if a data value in one sample can be paired with a corresponding data value in another sample. Now, on the first one, suppose you were comparing, I don't know, maybe a variety of soybeans, and you were looking at the average production of soybeans from plants in sandy soil compared to those in very muddy or rich soil areas. Those would be independent from one another. One plant has nothing to do with the other. Where you have paired data would be like, suppose you want to know the difference in height of the soybeans, so you, in a certain time period, then you could measure a plant halfway through its life cycle and then measure it again at the end of the life cycle. And anyway, situations like before or after. You could also apply this to diets, your weight before compared to your weight after. That would be dependent. If you were looking at your weight loss versus someone else's weight loss, that'd be independent. We are going to look at confidence intervals for differences between two, and mu1 is going to represent the population average of group 1. Mu2 will represent the population average of group 2. As far as the direction goes on here, if you have a confidence interval and the difference of means contains all positives, and what that would be is, say, mu1 minus mu2, if they're always positive, then that just means that the average of group 1 is going to be greater than the average of group 2. You can set it up just like an algebra problem. If you run into a case where your confidence interval contains all negatives, then that is the same as claiming group 1's population average is always smaller than the population average of group 2. If your confidence interval contains positives and negatives, you can't make any conclusions, because 0 is between positives and negatives, so you can't make a claim one way or the other. So just be aware that later on, when we actually do compute confidence intervals, we're going to be looking at the sign as well as the value of the numbers in those confidence intervals. So the next few videos are going to be able to over conducting these confidence intervals or constructing confidence intervals with SALT and a TI-84. And so I'm going to go ahead and end this one. This is just preliminary information and building vocab. Okay, so look out for the next two videos.